Hello everyone, we will be discussing our own eye structure today with you because it seems like an important topic for your examination. So friends, I want you to remember a time in which you had to put a thread across the hole in the needle. You kind of shrink your eyes to do so, right? Have you ever just switched off the light in your room and then that is pitch darkness, yet after a while you can see some stuff, although not in proper color, but we can see grey, white or black things. So friends, this is all because our eyes have lenses, and just like when using a camera we can focus on different things, our eyes also can shift the focus to make a sharp image of the object that we are seeing. This is our eye. If you will just take it out, it will resemble a ball. Hence, we say that this is the eyeball. Its diameter is on average 2.3 to 2.5 cm. Now let's have a look at the structure. This is a thin transparent cover in the front of eye called cornea, which you can also touch with your fingers. This layer is continuous with sclera, which is the white color layer of the eyeball. You can see the colored part behind the cornea, which is called iris. Iris is the reason why we see people with different eye colors like black, brown, blue, etc. It's a dark and fleshy screen. You can see an opening point in the cornea. This is called the pupil, from which the light enters our eye. Please remember that the maximum amount of light is refracted by the cornea, and pupil controls the amount of light entering the eye. So in the darkness, the rays of the light that are entering the eyes are lesser, so this pupil will widen to capture the maximum amount of light. On the contrary, it contracts when there is bright light present in your environment. You see, we can move our eyes to see the object on left and right. This is because of the eye movement, which we can do thanks to the muscles attached to the eye. Now comes the lens. Behind the pupil, a double convex lens is present. Now friends, lens can provide small adjustment to the focal length to focus the image. This we have seen in our example of putting the thread in the hole of the needle. Here we have the ciliary muscles and the suspensory ligaments that connects the ciliary muscles with the lens. Now on the back side you can see this layer which is below the sclera. This is called choroid. It is highly vascular layer, meaning it has a blood supply, thus it provides nutrition. Below this we have the retina, which you already know is the site where the image is formed. It is made up of light sensitive cells, rods and cones that gets excited when the light falls on them and generates electrical signals. Rods are responsible for the vision in dim light, while cones are responsible for vision in bright light. So in our previous example, when we switched off the light, rods were responsible for the vision. Cones are responsible for the perception of color. You may relate C for cones and C for color. Now you will see that the retina is not continuous, there is a gap here, which we refer to as an optic disc. This region has no rods and cones, so no image forms here, and it is also called a blind spot. Just behind this is our optic nerve, which will send the signals to the brain. The image formed on the retina is real and inverted. But ma'am, we see the object as it is. It is not inverted, right? This is because our brain analyzes the signals received from the eyes and converts them in a way that we perceive them. Hence, we see the object as it is. When an object is close to us, the light rays are diverged when they enter our eyes. So the lens needs to bend the light, right? This will be done when the focal length is less. Why so? Because when the focal length is less, there is more bending of light. Here, our ciliary muscle contracts, suspensory ligaments relax, and the lens also relaxes, thus becomes rounded, in the process decreasing the focal length. So it can bend the light, creating a sharp image on the retina. Now let's have the case when the object is at infinite distance. Then the light rays coming from the object entering our eyes are almost parallel, and we don't need to bend them much to form an image. So the lens becomes flatter. Can you guess how? Yes, the ciliary muscles will relax, so suspensory ligaments are stretched, which in turn will stretch the lens, making it flatter. Now the focal length is increased and focusing power is decreased. Hence, the light rays are not bent that much and the image is formed on the retina. The capacity of the lens to change its focal length as per need is called its power of accommodation. But of course, there is a limit of it. Now, what if I move an object very close to our eyes? Yes, you will not be able to see it properly. If you still put pressure on your eyes will be strained. You might have watery eyes and there can be pain as well. So there must be a minimum distance at which an object should be kept from a normal eye for a clearly visible image to be formed on the retina without any stress on the eyes. This is called as minimum distance of distinct vision. The position of the object at the distance is called the near point of the eyes, which is 25 cm for a normal human eyes. Similarly, we also have the farthest distance of an object from the human eyes at which it is clearly visible to us without any stress on the eyes. This is called the farthest distance of distinct vision. The position of the object at this distance is called the far point of the eye, which is infinity for a normal human eye. Here are some previous year's questions on this topic, so you know it's interesting as well as beneficial for you to study our eyes. Happy learning!